this PCB only has two temperature thermistor, it will mean that this thermistor right here controls both the charging temperature, battery temperature, and the CPU temperature, which I will show you what I'm talking about soon. So as you can see right here, we have the number right here. You're just going to highlight the number of the thermistor, then copy it. You're going to copy it right here. Then you're going to come to the PCB layout right here, and you're going to paste it. So once you search the number of the thermistor right here, it would automatically find the thermistor in this PCB layout right here. So you can see the importance of the PCB layout. It shows the path in which a particular component is on a mobile PCB. You understand? So as you can see right here, let me zoom in a little. You can see right here it has circled the thermistor. So from here, when you hold the mobile PCB in front of you, you'll be able to find where this thermistor is on that PCB. So coming to the guideline right here, which like I said, not all models have PCB guideline. It's just an easy way to show the component on the PCB. You understand? So like I said, if you come right here and zoom out, you will see that we have the thermistor in this point right here. So going to the guideline right here, we'll be able to find that thermistor. You understand? So just take it as if, yeah, this PCB is in front of you, then you are going to find that thermistor. So this is our CPU right here. This is our CPU, and the thermistor is beside the CPU. So if you come right here, again, you will see that it's here. You understand? Let me go back to the guideline, and this is the thermistor right here. So here is the thermistor. You understand? So if you are doubting if it's really the thermistor, I'm going to show you how you can find it another way, how you can be sure if it's the thermistor. You understand? So this is the thermistor right here. So if you want to be sure if this is the thermistor, you will go to the bit mapping. So you see the reason why I told you that you need to open all these stops. You understand? So that, yeah, because all of them are very important. So if you come to the bit mapping right here, this is the side of the PCB in which we are working on. And if I zoom into the CPU right here and come back to the PCB layout right here, you will see that we have the thermistor. You will see that we have the thermistor, we have a resistor right here, two capacitors and one IC right there. And if you come to the PCB bin mapping right here, you will see that, okay, here we are in this section. You understand? Okay, great. So you see what I'm talking about right here. So you can see that, you can see the names, arrow, which stands for resistor. We have resistors, we have two capacitors, and the IC that I was talking about. Then we have the thermistor. As you can see the name right here, it's written TH4000, which that's the thermistor that we are talking about. You understand? So if you are having temperature errors like phone temperature too high, the phone needs to restart, all that stuff, on this particular PCB, you can replace this temperature, or we just remove it. If you remove it and do not replace it, the phone will still work fine. You understand? I'm going to show you again on another PCB. So the reason why I'm showing you is because this PCB has only two temperature thermistors. I want to show you in another PCB right here, because the PCB might have three, in which one might be in the charging around the charging section, around the charging port, something like that, because most phones have battery temperature sensors in that section. You understand? So we are going to try that in this model, which is Samsung Grand Prime. So I just want to show you what I'm talking about. So if I come to this Samsung right here, we are on a different model right here, so keep that in mind. If I come there, then I search CH. Okay, great. So you can see that we have three temperature thermistors right here. 3 temperature thermistors. I already explained we have the one in the power section, which can be in the charging, around the charging port, or the CPU, depending on if it has only 2 thermistors. So like this one, it has 3, which means that we have the one of the CPU, the one of the charging port, then we have the one of the network section. You understand? So how are you going to find this on this PCB in case you are working on a Samsung Grand Prime PCB or anyone that you are working on? You are just going to search the TH right there, it shows you. Then you are going to go through these thermistors one by one and see their locations. So you are going to troubleshoot all these. You troubleshoot all this depending on the type of error that you are getting on that PCB. So if you are getting an error like you connect your charger, then you see an error message like just that, a temperature sign, or showing a charging temperature too low or too high, then you are going to find that temperature sensor in the charging section on this particular PCB. You understand? You are going to find the charging temperature sensor. But if you are getting error like phone temperature error is too high or too low and phone needs to restart, all that normal temperature errors, then you are going to find the temperature around the CPU. You understand? Okay, so I'm just going to click on one sensor right here. I'm going to click on one sensor, then I'm going to copy. I already showed you how you can do this. So in this PCB, I want to focus on finding the temperature sensor that it's in the around the charging card or around the charging section. You understand? Because that's the most troublesome one. You understand? Like I've been seeing most comments and most inbox like saying the phone cannot charge because of a temperature problem. So this is the most common issue that we get. So I want to find that temperature sensor that is always causing that using schematic diagram, so that you can use this method to easily solve that. So it's very easy. I have searched the first thermistor in this PCB and I'm going to copy it. So as you can see right here, this is our temperature thermistor, which is TH400. So I'm going to copy that and I'm going to come to the PCB layout right here and I'm going to paste it, then search where it is. Okay, great. So from the PCB layout right here, it shows where that temperature thermistor is, and this is exactly what I wanted to show you guys. So you can see that it's in the down section of the mobile PCB, which is around the charging port. So this is the temperature sensor that always causes that charging problems. Those charging problems, you connect, the phone can't charge, it's just showing the temperature icon. So this temperature sensor right here is always the one causing it. So if I'm trying to troubleshoot this temperature problem right here on a phone, I just use this schematic diagram, find the temperature sensor, then I'm going to remove it or I'm going to change it and everything will be okay. You understand? So for you to be sure again, I'm going to zoom in more, then I'm going to open the PCB guideline to show you that temperature sensor where it is. You understand? So this is the PCB guideline right here. So right here, as you can see, if it's complicated to know this while just looking at the PCB, you will need to open the bit mapping. You understand? So I'm going to open the bit mapping if it's kind of confusing, because at times the PCB layout shows different way in which the components are being placed. And if you use the bit mapping, you'll be able to find it. I'm going to open the bit mapping of this right now. I just opened the bit mapping. So let's go down to the charging area right here and find where that temperature thermistor is. So when you zoom in, it will name the components right here, and this is where you will easily find it. So as you can see right here, it shows that it's right here around this section in this particular component, but I tried finding it using the PCB guideline right here, which is just like the PCB in front of you, and I wasn't able to see it in that position. So using the bit mapping right here and checking the names, then you will be able to find it. You understand? So as you can see right here, we have TH right here. You have TH, which is the temperature thermistor. So this bit mapping right here will show you the exact position in which it is in that mobile PCB, and you will be able to do anything. You understand? So you can use this method to find any temperature sensor on a mobile PCB. You understand? You can use this method to find temperature sensors and solve any type of temperature error. You understand? So like I said, if it's given a particular type of temperature error, you need to know where you are going to remove that temperature sensor. You don't have to go remove the CPU temperature sensor when your phone is not charging because of temperature error. You understand? That type of fault, you will go directly, especially in this model that it has a charging temperature sensor CPU. Then in this type of model, you have to remove the charging one. You understand? Not the CPU one. But in the other PCB that I showed, it shows that the CPU is integrated with the charging and the battery temperature sensor. You understand? So like I said in the beginning, if you want to troubleshoot, do this deep troubleshooting, you need to change the battery first, because the battery itself has its own temperature sensor. You understand? When you change it, and it continues, then from there you will get into the PCB this way and start troubleshooting. So if you are new to my channel, make sure that you subscribe and comment right here so that I will know what you want me to make next.
I received this mobile phone today. This is iPhone 11 and the phone is acting really weird. Okay, wow, it went off. So what this phone is doing is that the phone automatically restarts out after every 3 to 4 minutes. Yeah, as I was speaking, it was on, right? So it's going to restart right here. So we are going to solve this problem today. It is a very complicated problem to know actually what is causing the problem. But let's wait for the phone to switch on. Then we are going to check something in the phone settings before we go on. Then open the phone to see how we're gonna solve the problem. Okay, we are going to go into the settings of this phone. The reason why I'm getting into the settings, I want to know the reason why this phone keeps restarting, because there will normally be an error message in the settings. I go to privacy and security, and I scroll down to analytics and improvement. So I will come to analytics data. Oh, did I switch off something? Oh, I'll have to hold on for the phone to restart again. Okay, after restarting, let's continue. We're going to get into analytics data right there. Okay, we are just going to search this panic. Okay, panic full. We're going to take the first one here. Okay, so I'm going to see the reason why this phone is restarting, then know exactly where I need to troubleshoot the phone. So I'm going to check this, then after I've checked, we will go in, open the phone, and I'm going to explain how I get to know exactly what to troubleshoot inside the motherboard at the end of this video. Let me see. Okay, so from checking here, I'm just going to open the phone right now so that we will troubleshoot and see how to solve this problem. And at the end, I will show you how I get to know exactly what part to troubleshoot and solve the problem, the restarting problem of this mobile phone. So keep watching and make sure to like the video and subscribe to my channel. And also, if you need my mobile repairing course, which is complete Android mobile repairing course, you can send me a message on WhatsApp. So let's fix this problem right now. Okay, the reason why I was able to identify where the problem is coming from is because if we check out the log, which is the restarting error logs right here, you will see that it says that the thermal monitor series returned. Yeah, that was the error. So this thermal monitor series, yeah, I tend to understand that it's the thermistor of the charging section. So the phone was not able to detect the thermistor was not able to send the phone signal that the temperature of the phone is normal and all that stuff. So the phone decided to restart itself. So the problem was coming from the charging card, and you can know that from here. So at times if it's the mic, it's going to show, like you see right here with the mic, it's going to show what part is missing in the mobile phone, and this make repair very easy to understand. So you can subscribe right here, make sure to like the video, and if you want Android mobile repairing calls, you can send me a message on WhatsApp. I received this mobile phone today and they say it's not powering on, so I want us to work on its PCB and see if you can revive the PCB. Actually, you are going to learn how to troubleshoot a dead mobile phone from this video. So looking at the PCB already, I can see that someone already worked on the PCB because the customer said gave the phone to one technician to work on it. So the person did not succeed. I can see that he soldered maybe cables in the Vbat, JND, all that stuff. So the first thing, we are going to use our multimeter to test the reading on the mobile phone, then see how we can troubleshoot and revive this phone. So when the customer brings the phone and say, okay, it's from a different technician, that's your best time to try so hard to revive that phone, so that okay, the customer will be like, okay, you actually know what you are doing and recommend more people to you. You understand? So let's get into this PCB and see if we can revive this PCB. Okay, here we have our mobile PCB, and like I said, someone already did something on the PCB, because if you take a look here, you will see some solder points there. Okay, so the first thing, we are going to set our multimeter. We are going to set our multimeter in buzzer mode, buzzer diode mode right here. Okay, we're going to set, so we're going to test the ohm reading of the PCB. We're going to test the ohm reading of the PCB, and we're going to perform a cold testing. You understand? So cold testing is best in detecting full and half shorting on a mobile PCB. So I will place my red probe on the GND, then use the black probe on the Vbat. So if you take a look carefully, you will see that the option in which the technician soldered right here is the Vbat. So we are going to set our multimeter probe, the black probe, in the Vbat. Okay, so the reading is not high, that's a normal reading, but because it's a normal reading doesn't mean that that the PCB is okay. So not every shorting can be detected from the Vbat, from the Vbat line. You understand? Not every shorting can be detected right here. It might be shorting on a particular section on mobile PCB, and you won't be able to detect it. So you can see the reading, it's 398. That's a normal reading for this battery connector. So we are going to test the battery itself. Set our multimeter to DC. So you can either use 20 or 200. We're going to test our battery just to make sure that the battery has a voltage. We're going to reverse. We have 2.6. Okay, we have 2.6. Okay, so right now what we are going to do is that we are going to supply the PCB with we are going to supply the PCB with our DC power supply, then try switching it on. So with our DC power supply, we will know if there is any problem in a particular section if there is half shorting or any problem in a particular section on a mobile PCB before we can then go on see how it goes. But if you connect our DC power supply and the phone switches on, that means that we will just have to boost up the battery. So follow up, let's see what's happening right here. First, we have to solder a cable so that we can connect it to our DC power supply, because this connector, I'm not sure I have it in my boot cable. So we're going to link a cable. This is the Vbat. We have to link it because we need to supply the phone with voltage. So we connect the Vbat. So actually I connect one cable. One cable is connected to the Vbat, and we're going to set our DC power supply to 4 volt. You can either set it to 4 volt or to 4.2 volt. That's okay for the phone. So we have 4 volt there. You don't have to worry about this. You can set it to 2.5. So that's okay. You can set it to 2.5. We are going to connect it to our mobile PCB. So this is the black. We are going to clip it to the GND, and the red, we are going to clip it this is not a normal reading, just from the DC power supply. Then my boot cable right here is giving the red light, which means that it's not a correct reading. So let's see. Let's test the power key. If you will get a voltage, the power key should be one of these. That's 0.70. That's an abnormal reading, 0.7 in the power key. So the DC power supply is going up to 0.8 milliampere. That's not a correct reading. As you can see, it's skipping. So it means that there is a secondary short in the PCB. There is a secondary short in the PCB. So what we are going to do here, if we increase the current, let's say 3.5. Okay, if we increase it to 3.5, that's actually a short. Shows that there is a short in the PCB. So you can see that's the current consumption when you connect it. So it's able to detect right here because we supply the phone with a high amount of current, which means that there is a shortage in the phone. So in this case, there will surely be something hitting up in the mobile PCB. Okay. There is a lot of heat in this section. There's a lot of heat in that section. I don't know if it's here or this other side. There's intense heat. Okay, so it's actually shorting. There's a shortage, even though the Vbat line is not shorting, but there is a short in the secondary section of the mobile PCB. So we are going to go into the mobile PCB and see the component that is causing the short, because there is a intense heat. The heat here is very intense. We are going to check that. So disconnect our DC power supply. Let's disconnect our DC power supply and work on the PCB. Let's find the section that is shorting. Okay, so the heat was coming from this section and it is other section. So we have access to remove this easily because it's a clipped shield. Wow, that worked out very easy. Okay, since we have the RF amplifier right there, so it means that, okay, we will have to remove this. And you have to remove this, then check the section. So we are going to do that right here. Let's connect the phone to the PCB holder. Okay, first let's disconnect the cameras because we will have to use our remote station. So these are things you have to take note when you are working on a PCB, so that you avoid having issues with the customer. And we are going to disconnect this cable first. Let's disconnect the cable for now. Okay, so this type of shield, you need to check the position in which you have to start removing it from. So you can see we have a little hole right here. You have to start removing it from this area, from this point. Okay, let's remove the shield. And remember, like I said, we have to remove the section. So we are going to send our tweezer, and you can also apply paste. You can also apply paste here. Apply it on this angle because we have a little hole to send in our tweezer, because we have to remove it from this side. So we have to send it there. Let's position this way. Okay, when you send it, you have to be like, okay, you are pulling this section downward so that you can try pushing it up. Do it slowly, you don't have to use force. Make sure you check the surrounding if you have any components so that you won't pull them off. So we go around. Okay, just like that, and we are good. The heat was coming from this section, so we are going to cool down the PCB without wasting a lot of time. We are going to use this cooler device here. I'm going to switch it on. Okay, this should be okay. That should be okay. Great. So there is surely a shortage from this area. We're going to test that using our multimeter. So we set our multimeter to user mode, and we perform a code testing again. So if you take a look clearly, you will see that there is no short in the Vbat, even though our DC power supply actually detected a short. And the reason why the DC power supply could easily detect it is because the DC power supply that I'm using has a short killer integrated in it. So here's the side I was hitting up. We are going to check this. Okay, you can see that the power capacitor here is shorting, and that's surely a PMU capacitor. So these two capacitors are shorting. So for us to know if it's the capacitors that are shorting or this IC, we are going to apply this on the PCB, then connect our DC power supply again to force the component to heat up. Okay, we're going to connect our DC power supply. Okay, that's my number in the screen. If you want my professional or basic level course, you can send me a message on WhatsApp. Let's connect our DC power supply. Okay, that's fine. So right now, we don't want the heat to be too intense. We are going to decrease the current to 3. Decrease the current to 3, then we solder the wire in the Vbat. We solder it. And we are going to use our boot cable. And okay, you have to take note of that section when we are connecting this. Let's see the one that is causing the short. Okay, so I'm just going to pin this, then increase the current slowly.
Going to pin this, take note of this area. So we have it right here. I'm going to pin it. Okay, seems like the section is okay. Okay, let's try it in the RFIC itself. Seems like the section is okay. Let's do that quick in the RF section. Oh, I'm even wondering why I did not spray this all over this section. Okay, I was supposed to do it. Okay, that should be okay. So I'm going to switch on my DC power supply. So take the of this area. This power supply is on, and you can actually see the short. Okay, seems like it's not from this area. Well, surely from here. Yeah, we're going to check the other section. We're going to check this section. So I'm just going to quickly remove this. Quickly remove the shield here so that we can work on the section. We are good to go. So without wasting time, we will just connect it. So let's find the shorting in this section. So we are going to spray the powder here. Going to spray the smoke here. Okay, we have our cable. And keep in mind, we have to focus on this section. I'm going to connect my DC power supply of the GND take to the ground, and we have the positive here. So let's take a look at this section. Okay, that will be DC power supply. Okay, we have the short and the DC power supply. Okay, if you look carefully, you will see that this IC is hitting. Let me increase the current a bit. Okay, that IC is actually heating up. The IC is actually heating up. Just to make sure that the IC is actually the one heating up, because the time it took for the spray to melt off, it really delayed. Meanwhile, the heat that we are getting from the PCB is really intense. So for us to actually make sure that this is where the heat is coming from, because the heat might be coming from somewhere else, but melting up the spray right here. For us to make sure that the heat is from here, you will have to at least spray this other side of the PCB completely. So you will have to remove this. Seems like what we have here, we have the charging IC, and okay, that's the sound IC also. Okay, great. So we are going to spray this section completely. Okay, that should be okay. Let's quickly connect our DC power supply again. Let's connect it. Did you see that? So it seems like the short is coming from the charging IC. Yeah, at least the charging IC is a component heating up here. Charging IC is the component heating up. And always keep in mind that the problem, because the IC is heating up, doesn't mean that the IC might be the one shorting. So because we have found the charging IC shorting, it shows that the power manager IC will need to be checked. So we will have to locate where the power manager IC is on this mobile PCB. It's not here, which means it should be here. It should be here. So we are going to locate that. And I was even thinking that maybe someone hit the PCB, but it seems like everything is here. Everything is here. And okay, this is the power manager section. Here's the power manager section. Okay. So always keep in mind that if the VPH line is shorting, it can either cause the power manager IC or the charging IC to heat up. The VPH is from the charging IC. The VPH is from this charging IC to the power manager IC. So if the VPH circuit has a problem in the power manager IC, it can cause a short circuit to heat up the charging IC. So from what I'm trying to figure out here, from where we are going to start troubleshooting, we will have to test some components around the power manager section and here also. Okay, so we will do a quick troubleshoot. Let's disconnect our cable again, and we are going to do a quick testing. Set our multimeter to booster mode. Then we are going to test the power section and the charging section. So if you have been working on solving shorting problem and you have a lot of experience, you will know what I'm talking about. So instead of just going on then to work on the charging IC, if you understand the schematic circuit of the Vbat, the VPH, which actually shows that the VPH line is the one shorting, you will know what I'm talking about. You will know why I want to focus also in the power manager section. Let me pull this down a bit. So we will continue with the core testing. JNZ, then we test. That's no short. Okay, we have a short. That's no short. So if I take a look closely, I can tell that these are CPU capacitors. These ones right here. Yeah, that's CPU capacitors because you have the CPU right here. So we have to focus on these capacitors beside the power manager IC, and you can actually see clearly we have a short here. We have a short, and let's come to the charging IC. That's no short, no short, no short. Still no short. I wasn't expecting to see a lot of capacitors without a short. Still no short, and that's no short. Wow. Okay, we have a short here. So the capacitors surrounding the charging IC are not shorting, but the charging IC is the one heating up. We have a few capacitors here shorting. So what I want us to do here, I want us to first remove the PMU IC. I want to remove and observe the points. Okay, so now that we have the power IC removed, we are going to check if the shorting is still in the mobile PCB. So instead of using our multimeter to test the components that we're shorting, we're just going to inject the PCB with our DC power supply with a voltage. Everything good. So you should be taking a look at the DC power supply reading. Let's do this. Okay, so the DC power supply is on, as you can see. So we are just going to place the black probe to see if there will be any local current consumption on the DC power supply. So this is it. Okay, so you can see we have a stable current reading there. There is no current draw. So let's try. Let me hold it here. Then let's try adjusting the current. Okay, it's 4. That's high. So it was supposed to give a reading in case if there was a short in the mobile PCB. So it seems like the short was coming from the power manager IC, because if it was not from the power manager IC, there will still be a short because the VPH line is shorting, which comes from the charging IC. So if you remove the power manager IC and we don't have that short and we don't have the short again, that means that the power manager IC was the problem. So what we have to do now, we have to change. I think I have this power manager IC in some form here. So we are just going to check the mobile PCB. I'm just going to check that, remove it, then we are going to put it on this mobile PCB and see if this works. But it's good how we have already detected the component that was shorting, which was kind of tricky because it wasn't the one hitting up. We are going to use a universal stencil because you can see I have other stencils right here, which is not the same with this power manager IC. We are going to use a universal stencil to replace the IC in which I have to swap this one with. You understand? Okay, so let's go on to make the solder balls of the older IC straight away so that I can cut the video short. The video is really long. I'm just going to get the IC, then we create the solder balls, then reball it and see if that works. Connect the black probe to the GND. So take a look at the DC power supply and the red probe here. Okay, no current draw, which means that there is no shorting in this mobile PCB right now. So what we are going to do, we are going to test the power button voltage and try to switch it on. Okay, we are going to check which one is the power key. 9.7 volt here. So we are going to switch it on from this area. Okay, wow, seems like we are good to go. Okay, so as you can see it's powering up. It then reach the boot information mode. So when you switch it on, it's going to go into the input mode, So it already surpassed the import mode, the trigger mode, import mode, and it's in the boot info mode. So the reason why it might not go up to reach at least 1 ampere is because the screen is not connected. So let's connect it to the screen right here, then see if if everything is good, because it shows there that it's on. At least at this point everything seems to be okay. It was the work was great. Let's connect it. Press hold. Okay, so it vibrates. So okay, if you take a look at the DC power supply, you can see the current consumption there. Shows that everything is okay, and the phone also made a sign. Okay. Okay, so everything seems to be okay right here. Okay, well, if you want my online course, you can send me a message on WhatsApp. I have a basic to a professional level course, so you can decide to get both of the courses, so you can get any of them, get the basic if you are starting, or get the pro level in case you already know how to troubleshoot, know how to read schematic. Because the pro level course is a circuit level in which you will try to understand every circuit, like I did on this mobile PCB, by understanding the primary section of the mobile PCB, the primary power section of the mobile PCB, the Vbat and the VPH, and that's the reason why I was able to know that the power manager IC might be the one causing the charging IC to heat up. Understand? So here we are good to go. Don't forget to like the video, subscribe for more amazing videos.
What you're about to learn in this video is not even available in my professional level course. Why? Because I learned this just a few days ago. I always tell you guys, we learn all day. That is how I basically learn most of the things that I teach you guys here. So this mobile PCB, this is a Samsung A70 guideline. And as you can see, I don't just have the guideline open. I have the guideline, I have the bit mapping, the PCB layout, which you can also call part number, and I have the schematics. We are going to study all these, finding how to solve network problem in this mobile PCB, because I failed to solve network problem on this particular mobile PCB a few days ago. And that's not because I wasn't able to know what I have to do at last. I knew what I had to do at last. The reason why I'm making this video is because I found out what I had to do, but I did not do it because the customer was not ready to pay. And it's a big lesson. Like I said, even in my professional level course, you are not going to get this knowledge, even though I've talked about the network section more better. But this particular thing that I'm about to teach you here, you can get it. And if you want my professional level course, you can always get it from the link in the video description, pin comment, or the link on my bio, or send me a message on WhatsApp using this number. So let's get into this video and see what we have here. As you can see, we have a very big network circuit here, and we're going to talk about this. So after checking the basics of this mobile PCB, I confirmed this IC was okay. This one was also okay. I never suspected this IC based on the type of network fault that you are getting in a mobile PCB. I never suspected these two ICs. So the IC that we were working on, that I was working on, was the main network IC. This is where the problem was coming from. So when I say this is where the problem was coming from, this is where I suspected. You get? So this is where I suspected. I put much effort to troubleshoot this circuit. First, you can see we have main power supplies as the main thing that you should troubleshoot and find when you are trying to solve network problem in a mobile phone. We have how many power supplies here? We have 4 power supplies getting into the main network IC. So what I did, I checked these power supplies. The VRAG 1.2 volt was missing we have the VREG 1 volt was missing, 1.8 volt was missing, and 1 volt was also missing, which means the only voltage that I got was 1.8 volt in this capacitor right here, and that's not that, and it's not that important, because if it was important that much, you would have gotten the main power supply in this guideline. You would have seen a line going to this capacitor from the guideline. So the only voltage that I got when the phone was on with the SIM plugged into the phone, I got a 1.8 volt. The 1.2 volt was missing getting into the IC. The 1 volt was missing, 1.8 volt was missing, and also another 1 volt was missing. So we have 4 different main power supplies that were missing. Okay, so now we know that, okay, the main network IC is not getting that voltage to power up and start operating. What next did we have to check? We set our multimeter to continuity test mode to test the components that the VREG lines are connected to. So for example, if you check here, you will see we have the 1 volt is connected to this capacitor. We check the continuity, the diode reading of the capacitor to see it is shorting to ground, because if the capacitor is shorting to ground, it's going to block the voltage coming to the capacitor. So we check the continuity test reading of this, the diode test reading. The diode reading was okay. We checked that of the 1.8 volt, it was okay, which is this, was okay. We checked that of the 1 volt, and we checked that of the 1.2 volt, which is this. So diode reading was okay, no voltage, which means that the reason why we are not getting any voltage, any power supply into the IC is not because of a short. So from there, what next do we have to do? We have to find the main power supply of the network IC. So with the help of the guideline, we are not going to use the guideline only. If you check, you will see I have the guideline open, I have the bit mapping, I have the layout, I have the schematics open. We are going to use all of these to troubleshoot this particular fault. So what I did was, I had to check the power supply, the component that is supplying these VREG voltages into this IC, because we don't have any single power supply here available. You get? So we followed the lines. You follow the lines. We have 4 lines. They are coming to this IC. If you take a look, you will see the mobile PCB has 2 ICs. We have the main power IC. We have another power manager IC right here. So if you check carefully, you will see that the 4 lines are coming directly into this IC, right? Using the guideline, it's not going to show you all the components that the lines are connected to, but it's going to show you the direct lines getting directly into the IC. And this is where the bit mapping comes in, because you need the bit mapping to know the other components that the lines are connected to. So what we did was, we are focusing on these 4 lines for now. What we did, we come back here, we see the components that needs to have a power supply for the network IC, and we go to the bit mapping of the mobile PCB. This is what we call the bit map. You zoom in to the circuit that you are working on. If you zoom in, you will see it has the same circuit, the same structure. All the components that are in the guideline, they are here. So we needed a power supply here. We needed a power supply here. If you click on it, it's going to show you. Let me see if it's going to have these lines. Okay, the lines are not available. I was supposed to click if the lines were available. I click here, it's going to show the lines so that you will easily see. But if you check the lines carefully, the dots carefully, you will see that they are blinking, right? So any line that is blinking in a mobile PCB shows that this line is connected to that part. So all I wanted to do, you have to click there, then you see the lines that the other circuits in a mobile PCB, the other parts that this line is connected to. And we are looking at this circuit. We are looking at this because the main power supplies are coming from here. So what are we looking at? We are looking for open circuit to see maybe if there is an open circuit between this IC and this area right here. So I check what I'm doing right here is exactly what I did when I was troubleshooting the mobile PCB. So if you zoom out, you will see that that one line was connected to this small capacitor, and from this capacitor it goes to this IC, as you can see. So how do you check the open circuit? One of your multimeter probe needs to be here, and your multimeter needs to be set in continuity test mode. You set one of your multimeter probe here to that capacitor that I showed you, then you have another one here. You are supposed to hear a beep if there is no open circuit. So I tested, I got a beep, which means that there is no open circuit, but which means that there is no open circuit between this line. So we did same with the other lines here. If you come right here, if you click here, you will see that it's connected to this part. We are testing, then looking at the other component that the line is connected to around this IC to see if there is any open circuit. You will see it's connected to this capacitor and also to the IC, because the IC is the main power supply. We tested, the reading was okay, continuity reading between the other point around the network IC and this point, it was okay. The diode reading between the IC and the capacitor was also okay. So we have another important power supply here, which is this, and we have another one here. So let's see where they are going to. You can see we get the power supply on this capacitor and the IC. The voltage leaves the IC, goes through the capacitor, it touches this capacitor, one side of the capacitor, then it goes to supply the network with a voltage. So you need to keep in mind that maybe if you have one open circuit in one of these lines, it can cause the other lines not to power up. That's what you need to keep in mind. That's why we are checking all the lines. We are not checking the lines to expect open circuit in all the lines. Just one open circuit in one of the lines can cause the other lines not to have a single voltage. So after checking, the reading was okay, and also we had another one here, very important. So you click on it, you check where it's connected to. You can see it's connected to here. We check and the reading was okay. And if you check and you see that there is no connection, there is no continuity reading between this area and this area, it means that there is an open circuit from here to here. And how do you confirm this? You switch on the mobile phone, you plug in your SIM card, because mostly the VREGs of the network section are mostly enabled. Sometimes when the SIM is plugged into the phone, this will be different depending on the mobile PCB, right? So you just plug in the SIM into the phone to be sure that everything is enabled in the network section. So if you plug in the SIM into the phone, then you check. This point is connected to this one. If you test here, you don't get the voltage. You test this part, you get a voltage. All you have to do, you jump out a cable, the voltage from here to this capacitor, and it will enable the other voltages. Or if only this voltage was lacking, the network IC will be able to get the voltage. We check all this and everything was okay. So what next? Do we have to do? First, you suspect this IC, it might need reballing. Everything works well in this mobile PCB. If it was all about reballing, at least one of the main power supplies of the network section would have been available, but none of the main power supplies of the network section are available. And because of that, I said, okay, I don't have to work on the power supply first, on the power supply IC, which is this power manager IC first, because I don't even suspect that, even though I'm not getting the voltages out of the IC to that. Why? Because this IC needs to be enabled by what? We are going to look into that. So if you come back to the guideline, you will see that if you check on this other network amplifier IC here, network RF amplifier IC, we will see that it has a data and a clock signal between the CPU and that IC. So this data and clock signal is very important. These lines are very important. You see the data and the clock signal. We have the reset signal, we have the clock signal. These lines are very important, and you can see the lines are between the amplifier IC and the CPU. But when you look at carefully, you need an enable signal. Even if the enable signal is not between the CPU and this IC, it should be between the CPU and the main power supply component that we are working on. We look at the enable signal here. You will see the enable signal is not available in the guideline. That's because we have a lot of integrated circuit. Not everything will be displayed here. Okay, so this is what you will need to understand here. The reason why you are not getting any output, any VREGs from the main power supply of the network IC. So the reason why you are not getting the output VREGs to the network section, but other parts of the phone are working, which means that the IC is working well. This particular IC is also the one supplying the display with voltage. Also the IC supplying the sound circuit with voltage. A lot of circuits are being supplied by this IC, but why only the VREGs of the network section are not available? That's because all the VREGs, which are the main power supply of the network section, needs an enable signal from a particular IC to be able to power up all these voltages. And if that enable signal is not available, you are not going to get any output voltage enabled to the network IC. So what we were looking at here, the reason why I was looking at all the lines that are going to the CPU is because I'm looking for an enabled signal to see if I will see any visible enabled signal to test the dial reading, and also to test a 1.8 volt in the enable signal, because the enable signal needs a 1.8 volt to operate, just like the clock signal line and the reset signal. We haven't seen any enable signal here. Why? That's because this mobile PCB doesn't have an independent baseband chip. Because of that, not everything will be displayed either in the guideline, the bitmap, the layout, the schematic. Not everything will be displayed there. If this mobile phone had an independent baseband chip that controls the network section of the mobile PCB, this mobile phone would have had another IC, which is the baseband IC, with all these lines connected to the IC. And with that IC, you will see a line, you will see an enable signal from that IC coming directly to this IC. And that enable signal of the baseband chip is the one powering up all these voltages going to the network IC. You cannot see that here because the baseband IC is integrated with the CPU. This main CPU of this mobile phone is integrated with the baseband IC. You see all these lines. You see all these lines. You have the data reset signal, the data clock signal. All these lines are that of the baseband chip. They are getting into the CPU in the baseband section, integrated into the CPU. And if you check this mobile phone, if it did not have an integrated baseband chip and CPU, if it had an independent baseband CPU, you will see that all these lines will be going directly to that CPU. And also you will be able to see a direct reset clock signal, enable signal, which is what we are looking for, from the baseband chip to the power manager chip that we are talking about. So like I said, this lesson is not even available in my professional level course, because like I always say, we learn all day, and all these things I've learned them recently. All these additional things I've learned them recently. Even though I've talked about the complete circuit, network circuit in my professional level course, still there are always new things to learn, right? You can get the course from the number you see on the screen. Send me a message or just go to my video description on YouTube. If you are watching this on YouTube, you will see a link to purchase my courses, or check the link on my bio if in case you are watching this on TikTok. So if you go to the what is it that we are looking for, you come to the power supply of the network chip. You come to the power supply, which is this IC. You are looking at the part number, the guideline, the layout of the schematic layout is also called part number, because you use it just to get the numbers of the IC. See the particular part in the mobile PCB where a particular IC is in. So we are looking for the main power supply of the network chip, which is this IC. And what we are going to do here, we are going to use this IC to get into the schematic diagram to look at the integrated circuit, the data sheet of this IC, to see if you will see a direct enable signal, because we are not able to see it using the guideline. So as you can see, the number is U5004. So you take that number, you come to the schematic section and you put the number there. When you do this, it's going to take you to the IC. As you can see, we have all the pins connected to the IC. So what we are looking for, we are looking for an enable signal on this IC, right? We're looking for an enable signal. If you check, you will see the schematic divides the part of the IC. You see we have different labels right here, which means that they are going to a different section, particular section of the mobile PCB. Like you can see right here, we have USB in, which is the V-bus line of this mobile PCB, but that's not what we are looking for. If I zoom out and look at the power supplies that we're getting into the network IC, you will see that we have the VREG output section here. So if you check here, you will see we have the VREG output section of this main power supply IC. You can see we have the voltages, these voltages. Here we have the voltages that are getting into the network section and the voltages that are getting also to other parts of the mobile PCB. You understand? So what we are looking for here, if you look at the IC, you should see an enable signal. You should see an enable line, and that enable signal should be coming from the baseband IC, and that is what we are looking for. If the enable signal was in a particular section of the mobile PCB, which is displayed in the schematic diagram, the enable signal should be around this section, because it enables the voltages in this section to go out. So let's see if you will see that in any section of the IC. So you can see we have the test enable VPP right there. That's not the enable signal that we are looking for. You don't get the enable signal here. No enable signal. The enable signal is supposed to be here if it's available. If it's available, we are going to see something like the VREG enable VREG, all that. So you are going to see that here. So we don't get to see that in the schematic diagram. And I bet that's because this mobile PCB doesn't have an independent baseband IC. So because of the complicated integrated circuit in the CPU integrated with the baseband, so if you take a look carefully, we cannot get the enable signal, right? So what next do we have to do? If you come back to the guideline, then we see the amplifier IC. The reset and the clock signals we're getting into this IC. The enable signal might somehow be connected to this IC also. So what do? We take the U1004. We come here, we check the IC and study the IC. We have U1004 there. If you check the U1004, you will see that this is the signal amplifier IC. If you check here, you will see we normally have the main power supplies that are powering up the IC. We have the data signal, we have the clock signal here. If you check all these other lines, you will see that we have no enable signal. It doesn't have anything to do with the enable signal. Why are we checking this? It's something that we are not even expected to see here. But we have different circuits, different schematic diagrams, how everything is connected. And when we study this, that's how we learn that different circuits have different connection. You might see this on this circuit, check that other circuit, and you won't be able to see it, right? So it's not connected here. So what it's left to check There is nothing left to check from here. Using the knowledge that I gave you when I talked about the baseband CPU, which means that the only thing left to do with a mobile PCB, the only way to solve the network problem of this mobile PCB is not to reball this IC, even though you can reball that just to try your luck. But I'm telling you, the problem is not coming from this IC. You might think the IC might have an open circuit or the IC might totally be damaged. That's very normal. But in this case, after doing all the troubleshooting using the same method that I've just taught you here, you will know that this IC is okay. What this particular section of the VRAG of this mobile IC lacks is an enable signal to enable the output voltages to the network IC. Which means, in this case, what you have to do, you have to reball the CPU. That's the only way to solve this problem on this mobile phone. This is what I was supposed to do. The customer was not ready to pay. I spent a lot of time trying to figure out. We get a lot of network problems in this Samsung mobile PCB. There are some I've uploaded videos. There are some I solved that in this network section. Some I just reball the power supply IC. And there are some that I don't solve. And I've checked online, I've seen a lot of YouTubers uploading videos, comment section, everyone is like, okay, I have the same phone. Even if you just check the A70 network problem, you will see a lot of people in the comment section having the same fault, this A series having network problems. So the reason why it took me a lot of time to troubleshoot this, even though I know that the customer won't be able to pay, was because I wanted to learn. And that's how I learn. That's basically how I learn everything. I take my time trying to study things, figure out. And like I said, to solve the network problem of this mobile PCB, the CPU is the one that needs reballing. The CPU is the one dealing with the enable signal. And if we have an independent baseband CPU in the mobile PCB, all we will have to do is to reball that baseband CPU, the baseband chip. But there is no baseband chip. It's integrated with the CPU. And the alarm so you smile right here. Don't forget to subscribe, follow me, and get my courses from the link in the video description, the pinned comment, or get it from the link on my bio if in case you are watching this on TikTok.
Okay, I received this Google Pixel 4 XL from another repairing shop and the phone is not switching on. So in this lesson, you will learn how to troubleshoot Google Pixel devices. So you will work together and try to revive this phone. As you can see, the phone was already dismantled, everything is clear. They already worked on the phone. Okay, so if you watch my other videos, you will see that I was working on a phone and I said I received a couple of phones from another phone repairing shop, and I will be working on those phones one by one so that you can see the full process. So this is one of the phones. So if you take a good look right here, that's a battery connector, and if you check right here, you will see that they sold that something there. So we disconnect the battery connector, and if you check again, you will see, okay, we have the we have the Vbat jumper point. They also sold that something. Okay, and if you look at the battery connector, beside the battery connector, you will see a screwdriver point, which seems like they use force to pull it off. So we are going to test the battery to see the voltage of the battery first. Set our multimeter to DC, then test the battery connector. So let's see. The battery is pretty low, that's 9 volt. No problem with that. Let's set our multimeter to diode mode, which is booster mode, right? Diode mode and booster mode integrated. So we use our red probe. We will perform a cold testing, red probe to the GND, and we use the black probe and place it in the Vbat. So this is the best method. You see that reading 346. It's in 346. So that stuff, that's a good reading. It shows that there is no short in the mobile PCB. Not generally, there is no short in the primary section. There is no short in the primary section of the phone's input voltage, which is the phone's Vbat line. So if we test, you see that we test the battery ID, we also test the B temp, which is the battery temperature signal line, and the reading is okay. So we connect our phone to our DC power supply. Yeah, to put it up, the battery is low, right? So we cannot be working while using the battery, which is pretty low. And for us to be able to identify where we need to start troubleshooting the mobile PCB, we have to use our DC power supply. So I'm checking to see if I have any connector that will go with the Google Pixel, and seems like there is no connector, right? So we will have to use our jumper cables right here to send the Vbat voltage into the phone. I have two cables right here, so I just have to solder one to the Vbat. So let me zoom in a bit. Okay, that's okay. So I will have to solder one to the Vbat right there, just like that. Yeah, keep following. Yeah, like the video, subscribe in case you are new to my channel. Yeah, this video is a very detailed lesson, so make sure not to skip any part. And if you want my professional level course, make sure to send me a message on WhatsApp. So we set our current, check at my DC power supply, set our current to 2.5. yeah, that's just for testing first. 2.5, and we connect. Yeah, wow, that's that's I wasn't expecting that. There is a short in the mobile PC. If it's checked right there, you will see that there is actually a short. Take a look again. I'm going to connect it again to see what's happening right there. So let me try pressing the power key, and yes, there is a short, a secondary short. The short is acting really weak, but we are going to see to that. Okay, so let's connect the phone to our charger. Then to see if you will see if the phone has any light running in the PCB. So you see there is no current consumption right there, which means that the phone is totally dead. Yeah, right, it's totally dead. So you have to go deep into the mobile PCB right here and troubleshoot. So let's open everything up, do this fast. Okay, so again, make sure you like the video and subscribe to the channel for more amazing videos. I create tutorial videos on how to repair, and if you want to learn everything in great detail, like for example, you see how I just connect everything in my DC power supply, and I'm like, okay, I actually know this problem, blah blah blah. I know how to read the DC power supply. That will be okay if you get my professional level course. So this is the PCB, and we'll be working on the PCB right here. Remember, I said there is a short, and one thing you need to understand here is that our multimeter did not detect a short, right? So which means that the short here is a secondary short, which will be in the VPH. You understand? So in this side of the mobile PCB, you have the charging IC there. Here we have the CPU and the hard disk. Yeah, the hard disk right there. So which means that we will be focusing on the charging section. We will have to check the VPH, which is the secondary line. Yeah, I have this cutter right here. It's very good. The reason why I'm using the cutter to remove the shield is because we have the hard disk, the CPU just beside where we will be working on, and we will try to not to use heat, because at times using heat you might end up not fixing the device, not because you could not find the problem, because just the heat caused some open circuits, short circuits on that the bigger ICs, all that stuff. So I try to cut it, but it seems like it's easy to go off, so I just pull it off. That's great. Yeah, really great. So that's the charging IC. Yeah, that's the charging IC, and we have the coil. Yeah, the coil, the VPH coil. So if you check the Borneo schematic diagram, I use Borneo schematic and STEC schematic to be able to know exactly where the VPH line is coming out from, because I know that the VPH is actually the line with the problem. So we will have to set our multimeter to buzzer mode again to check for shortage in the secondary section. Like I said, the VPH should be the problem, and just set and go straight to the Vbat. That's the Vbat input of the charging IC, and that's the VPH. That's a short. That's a short in the VPH capacitor. That's the Vbat, no short. The VPH next to it, all the capacitors connected in the parallel in the VPH line, they're shorting. Okay, we'll have to work on that, because we have seen the shorting capacitor doesn't mean that we'll be solving the problem just now. Okay, so you have to desolder this. Remember, a lot of capacitors were shorting there, so we have to use our jumper cable. We have to jumper the cable right there, then use our smoke or dust powder, you can call it rosin, flux, yeah, you have to use it, then connect it right there, and yeah, you see it cannot heat up. If you check the DC power supply, you will see that there is no stable, the voltage, and both the voltage, the current is not stable, which means that it cannot heat up any IC. So until we set the current and the voltage in the way that it can heat up, you won't be able to see any reading. I try adjusting, so it keeps on going off, which means that we still have to adjust. So depending on the section that you are working on, I connected 4.2 volt to the VPH. You need to know the section in which you are working on to be able to know the voltage. The 4.2 volt is not bad, so I reduced it to 1.8 volt, which is a safe voltage, and increase the current completely, and now it's a stable 4.2 4.1 consumption. I test right here, and there is heat in this section. There is heat in this particular section, which means that you can see the other capacitors in the other side doesn't heat up. Yeah, so let's open this using our safe method again, cutting this. So this one is pretty hard, so I have to cut it all round rather than just pulling it like I did in the other one. But at times when you start cutting it, you will see that it's easy to remove and you can easily remove it. But I just cut this one right here, and I will later remove it because it might be hard to get into the case. But for now, let's focus here. So this phone have two power ICs, and this is one of them from the schematic. You can use STEC or Bonio like I did to know where the power ICs and how many power ICs. So I soldered this cable. I have to solder this cable right here. Then yeah, spray our powder here again, smoke or whatever you can call it. Just spray that, then yeah, we will have to check the heating component in this section because the section was heating up. So here under our microscope right here, and yeah, everything is clear. We'll have to connect it to our DC power supply to see what happens here. So we are connecting, and boom, you see that, right? So that's heating up. That capacitor is the one heating up from this section, and the capacitor is bad. So yeah, let's just hope that we solve the problem. That's very clean. Well, let's just hope that we solve the problem by removing this. But because you have seen the heating capacitor doesn't mean that okay, you will succeed. Nope, that's not how it works. So that's the capacitor. We just pull it off. Yeah, you can still not replace it. It will work fine, but I recommend you replace, but I won't replace. Yeah, so let's make sure everything is clean. Set our multimeter to buzzer mode again to make sure that the points of the capacitor that we just removed is okay. Yeah, so we have to perform a cold testing, test the point. Well, I wasn't expecting it to read. That's still reading. There is still a short in the mobile PCB. We still have a lot of work here. Then man, that's a lot. So we still have to work on the PCB. This is crazy. It's crazy. So let's test the other side. Yeah. Yeah, the VPH is still shorting. The short is still there. the short is still there. So we still have a lot of work here to do. Still have a lot of work. So I'm suspecting the capacitors in the section, to be sincere right here. I'm suspecting the capacitors around the power, the charging IC. Yeah, the ones that we were first working on. So we will have to go under the microscope again. What I did here, don't know. Yeah, that's not a problem. That's not a problem. You just have to spray the powder again and focus the heat on this section. There is a possibility that, yeah, we will have the chance to heat up since we have removed the other bad capacitor. So inject it, and boom, we see that that's another bad capacitor directly, which is even the first component, yeah, the second component in the VPH line. So clean everything, make sure everything is very clean, and pull this one again. Yeah, pull it off. That guy is bad, and you have to clean this solder here. Clean it, and yeah, inject it, and everything is clean, right? So make sure that everything is clean, and we see how things be right here. Okay, so right here you can see that this is the VPH line, which is the secondary voltage. That is why you are not able to detect the short. And this is me right here, yeah, working late at night. Yeah, so I'm actually doing a voiceover right here. I like to do certain things late at night, so I don't usually record while I'm filming. That's why most of the time my voice is sounding tight, because I always record late at night. So right here, let's test the PCB. Let's test the PCB again. Let's test the VPH line to see if the capacitor was the one causing the short. And yeah, I have to connect our red probe, performing a cold testing to the GND, and we use our black probe test the side of the VPH, and that reading is okay. That reading is okay. There is no short in that point again. Yeah, we remove the short, and let's test the other side in which we first removed the capacitor, which was still shorting. And there is no short. Let's hope everything works right here. But keep in mind, and in most cases you wouldn't succeed even by removing the short, which is why you have to continue watching the video to see what happens next. So what we'll have to do, you'll have to connect it to our DC power supply now that we have removed the secondary short, which seems to be the problem of the phone. And we will have to inject the phone to our DC power supply to the phone, something, how you want to take it, then breach the power key and see. Okay, that's a good reading. Let's wait a bit and see. That's a good reading, but oh, not a good reading. But the phone actually tried to switch on. It surpassed the import mode, was around the boot mode, yeah, from the DC power supply. So it's stuck there, and I think the reason why it's stuck there is because there is no battery ID signal for the phone to boot up. Exactly. So we just quickly put everything together, then try to on the phone using the battery itself, because it will have the battery ID. Yeah, let's try switching it on, and you can see, like I said, it's not identifying the DC power supply as the battery because of the battery ID, right? Which means that we will have to put the test with the battery. The battery will have the ID, the B temp, and every signal that the phone needs. So let's connect the battery. I activated the battery. I boosted the battery, and let's see, and no power. So doesn't mean we haven't succeeded. Okay, so from here I think the problem is the battery, because I boosted the battery. I tested from
from the before the circuit of the battery. Like right here, I tested from the pins before getting into the circuit, and I have 4.5 volt there, and I tested the flex, the connector that connects to the PCB, and there's only 2 volt, which means that the circuit has a problem. So you see right here, we have the positive of the battery. We are working on the circuit right here, the negative, sorry, the negative, and we have the fuse resistor of the negative battery line, and we have the fuse resistor of the positive battery line. So instead of just telling the other technician or the customer that you should change the battery, instead we know that we can actually do this, fix this. So I noticed that the positive line has a short in voltage, like the voltage is not completed, it's not getting into the 4 volt from that resistor is not getting into this fuse resistor to go to the battery connector itself. So I quickly do this, use my UV light to cure everything, and quickly I worked on the battery and I got the voltage. I put in everything right there, and let's see if we succeeded in working on this guy, Google Pixel. They are really crazy, and boom, everything be good right here. And because you have seen the onion logo doesn't mean everything is okay, so you'll have to wait to see if the phone can actually boot up. Okay, so now that the phone is on, yeah, it's great, right? It's great, but it doesn't mean that you have succeeded. We did a jumper in the battery. We have to check if the phone is charging, and it's charging, which means that our jumper was okay. Yeah. Everything be good right here. Make sure you like the video, subscribe to my YouTube channel, and send me a message if you want to learn mobile repairing, starting from the basics of troubleshooting to the professional level of troubleshooting and fixing every mobile phone fault.
We have this mobile PCB received from another shop. So the mobile PCB is water damage, and
if you take a good look at the device, you will see that the phone has a new display. I did not try to know exactly why the display was replaced, but yeah, the phone is not powering on.
So as we normally do, we are going to open the phone. We are going to dismantle the phone, and I think the first thing we have to remove the back cover. Okay, as you can see, we have access to dismantle the phone from here. We are going to do that right away. So let's see, because it's a water damage mobile PCB, yeah, we are just going to see what we can do. First, let's connect it to our charger and see how it's behaving before we go on up. So open it. Even though just connecting it, I'm just connecting it to my charger just to see how it's behaving. Even though I'm still going to open it, but let's just connect it first, then see. Let me just connect it here and see. So what we are going to do, let's go on, then open the phone and see, because there are times that it might show that current run. You will think the phone is charging normal. Meanwhile, even without the battery, you will still see that current draw, which in such cases, it's going to be a current leakage. So that's why when you see that type of reading, the phone acting as if it's charging normal, you just have to go on, open the phone, disconnect the battery, connect the charger again, and see if the phone is going to consume that current. So like I said, they already worked on it. If you take a look, you can see that that's clear already. Okay, you can see clearly they removed the shield and put it back and soldered the shield back. So okay, so this is the first thing that we are going to do. We disconnect the battery to connect the phone on charge and see if you will see that current consumption again. Nope, we are not getting that current consumption again. We are getting 0.3. So that's quite normal in some PCBs. Some PCBs will consume this little current without even connecting the battery. So it seems we have to get access to the PCB first. Okay, here we have the PCB. This shield was removed completely, and we have the clipping shield here with the clipping covers. You can actually remove this without heating up, but this one is different. I wonder how the circuit was when they removed the shield, but yeah, we are going to see to that. So first, what do I have to do? I set my multimeter. I will set my multimeter there. That's continuity test mode. I perform a pole testing. My red probe goes to the ground like I always do. And I test the positive side of the battery connector. That's 328 ohm. And that's okay for the Vbat line. Keep in mind, like as I said, for the Vbat line, doesn't mean that the PCB is okay. Even if there is a short maybe in the VPH line, you are still going to get a normal reading in the Vbat. So this is just to check and see if the primary section of the mobile PCB is reading okay. And the reading is okay. Yeah, so you will have to connect this to our DC power supply, then see how it's reading. So what we are going to do now, we are going to connect the PCB to our DC power supply. So I will just solder two cables. So we have the GND cable soldered to the GND. And then we have the Vbat. Let me take a look carefully. Yeah, we have the Vbat soldered to the Vbat. And yeah, just like that, we have two cables soldered to the PCB. So what we are going to do here, I will set my DC power supply reading to 4.2. So let me just show you my DC power supply. That's 4.2 reading, and we have the amp set to 5. 5 is okay, so don't worry about that. We have 4.2 volt. So I will connect. That's the black probe, and we have the red probe here. So from the reading, since the phone has a problem with the CPU, maybe just open circuits. Let me just show you. So I will try switching it on again so that you will see how the phone is behaving. You will see the trigger. So as you guys see, the arm is going up to 0.160. So I'm still pressing the power button. So if I leave the power button, you will see that it's going to stop. So the phone is actually doesn't have a stable trigger, and if you see, just with a single tap it goes up to 1 something. So this is definitely a problem with the CPU open circuit, and also it can also be the power IC not supplying voltages correctly, maybe due to a damaged component or open circuit also in the power manager IC. But with that reading, the CPU will need reballing. I don't know if it has a double mount CPU, but the CPU will need reballing. And before I go into the CPU, it's a water damage phone, which means that the problem can be coming from any section. So I will have to check the PCB step by step before I reach to the level of the CPU. So we will have to observe the PCB well before we go on checking the CPU. We will have to observe the power IC section. You will observe the power IC section, and you will observe the power IC section before, and the charging IC section. Observe everything in the PCB before getting into work on the CPU. So I will remove the first shield. This shield, the other technician removed this shield, so that will be the first one for me to remove, then observe the area. So if in case you are watching, like especially when we were reading triggering the phone, then reading from our DC power supply, if you are wondering how I get to tell where the problem might be coming from, that's because I know the boot sequence of mobile phones. I know the numbers, the current consumption, and what components are consuming a certain voltage, and because of that I'm able to tell where fault reading, and I'm able to tell that this specific reading is caused by this and I need to check this section. And also anyone who has gone through my professional level course will know this, because I teach that in my professional level course. So I will observe this under my microscope to see what's going on.
Looking at the PCB, you will see that that area is okay. I think this happened when the other technician was removing the shield. So I had to remove that shield of the charging section to observe to see if there is any water corrosion in the PCB, and as you can see, everything is clean. And here we have the processing section, which includes the CPU and the eMMC, and it looks good. Yeah, it clearly shows that there was water inside this area. And yeah, just observe, clean everything, then go on with what we are planning to do. Yes, that's the charging IC, I think. And here we have the power manager IC section, and also it's clean.
So what I want us to do now, I just want us to go on then, reball the CPU. If possible, we will also reball the eMMC. So I'm going to tape the eMMC. I'm just going to tape it so that the heat won't affect it when I'm working on the CPU. So I use this tape so that it will block the heat when I'm working on the CPU. Okay, so we can start the CPU work right now. Okay. Let's see the temperature. So when I'm removing a CPU of an Android phone like this, I'm always like, okay, what if I don't get the stencil? Because even though I have a lot of stencils, there are still times that I'm going to remove, and I will see that I don't have the stencil. And not all types of CPUs can work with a universal stencil. Even if it can work, it's always a lot of work, and it doubles the work. Well, we have the CPU that we want to revolve here. So we will just go on and clean the PCB. So I just go on, then clean the solder parts of the PCB. So this type of things you have to do them slowly. You don't have to rush at all. You don't have to rush at all. And these are the type of things that you get perfect in while doing practice. The more you work, that's the more you get perfect in doing this type of stuff. So it doesn't matter who your mentor is, how good he or she is, you will always get perfect by doing practice on your own when it comes to this.
So when you are looking at those components, making sure I don't wipe off any components. As you can see, we have this huge solder here. That's how you take it off. Okay. So once everything is clean, as you can see, you take a look at the solder part, then see if we still have some sections there that you will need to touch with solder. So you see sections like this, you need to retouch them with solder. If not, when you reball, there is a possibility that some of them are not going to connect with the solder balls in the IC. So I just put that. And that's it. And also, when it comes to micro soldering, a lot of people are always asking me, what can they do if their hands are shaking, that their hands are shaking? How can they do micro soldering? Yeah, I can tell that most people have shaky hands. Even me, I also have shaky hands. So when you do, that should be one of the reasons why you should be very careful when working. Take your time and avoid working when people are looking at you. Someone like me, I'm not really that good with social. So I have that kind of social anxiety. That's why I always work when places are quiet. So if you are that type of person, even if you have a public shop, when it comes to micro soldering work, you can always do them at night. If you don't work at night, then you should try make your working place secure your working place in such a way that people are not going to see you when you are working. So if you have shaky hands, it's going to be very hard for you to work while people are looking at you, because this happens when you are kind of nervous. It's not like it's because you don't know what you are doing. You know what you are doing, but you are kind of nervous just because there are people looking at you. Because the way that I'm working now, I cannot work the same way especially if just one random person stands here and start looking at what I'm doing. I won't be able to work. So that's it. Yeah, that looks okay. So let's work on the chip itself. The solder of the chip, and then the next thing will be to do reballing. So when you are doing this, you have to do clean so that you will see all the solder parts. Well, see the ones that you have to work on. Okay. You see these brown areas, these are sections that if you just go on to reball the IC now, you will see that solder is not going to attach to those particular points. So that's why I said it's always good to clean. Then take a look at sections like this, then see how you can work on them. There is one piece that I see they're using, most Chinese guys are using online now. Just like when you just use it here, it's going to easily clean off this area. But I don't have that piece, so I do it manually like this. I do it manually just like this. So you need to use soldering paste when you are doing this, so that everything will be clean. And when you do that and you see that everything looks clean, then you use your soldering wick to clean everything again. So you will be cleaning now for the last time. Just do this for the last time. You don't have to use force, if not you are going to damage the IC solder part. So you do it just slowly. Okay, I think everything is good now. So let's go on and clean the IC and go on to make the solder balls using our stencil. So I don't know for now if I have the stencil for this. I just hope I do, because using a universal stencil is like kind of boring for real. Especially as you can see, is consider the IC have some space in between the solder balls, and when you are using a universal stencil, you will need to take more time, just because I think you do understand. Okay, everything is good to revolve. I'm just taking a look at the solder parts to see. Okay, perfect. So I have a lot of stencils here, and luckily I got the specific stencil
So now you need to change loud. So why the music seems so loud? When we feel this loud, baby, it's bad, it's bad. So when you heat up the solder balls, and there are times that you might want to separate it from the stencil, and you will notice that maybe one pin is missing, like not connected. That's why I always remove it slowly, so that because at times if I notice that one is missing, I can just put it back like this, then heat it up. I can remove it completely, then put it manually. Now it's time to reball the CPU. As you can see, I'm putting the paste. I always like to put the paste just a little bit, so that when I'm putting the IC, mounting the IC, it won't be going up and down. So I put that little paste just like that, and I position the IC. So if you are someone who doesn't have stable hands, you should position the IC perfectly before you start hitting it. So that's what I do. I position it, then I turn the IC around looking at the corners. You can see those little lines. You need to make sure that the IC is in between the little lines, and which means that it's well positioned. So I did that, hit the IC, and the phone did not switch on, but it was acting differently. So after reballing the CPU, pressing the power key, I noticed the current will go up to 150, then come back to 90, and will be stuck at 90. So that showed that okay, there is surely an open circuit in the eMMC as well. That's the eMMC that I'm working on here. And I made the eMMC solder balls using a stencil, as you can see, just like that, and very smooth. And you just remove it just like that. Don't forget to send me a message on WhatsApp or get my courses directly from the video description, pin comment, or the link on my bio if you are watching this on TikTok. So this is time to mount the eMMC. So I did the same thing that I did when I was mounting the CPU. Place it position, then hit everything up just like that, and very smooth. So when I was done hitting everything up, it's time to test and see how everything is. So when you press the power key, the phone vibrates and no display. So I called the other technician. He told me that he can only bring a display next week. But if you listen, you will hear a boot up sound. You get that? So that's the boot up sound. That shows that the phone is actually powering up. Now, because when you press it, it's going to vibrate, and after some time, it's going to make a sound showing that it's booting up. So I want to connect it to my PC so that we can check through the device manager. If the phone is on, we will know the phone is going to detect it on MTP mode. So I'm just going to connect that, then we check our device manager. That's the phone being detected. As you can see, MTP USB device. So any technician should know that this phone is actually on on the home screen at this point. So everything is good. I'm just waiting for next week for the other technician for the technician who gave me the phone to bring a screen so that I can connect test. If it doesn't display, then I can check the display that time. So as you can see, it's a new display in the phone, like I said in the beginning of the video. So if there is anything, I'm going to check, but I think that the problem is the display at this point. So it was a successful work.
Okay, so what are we starting with? I want us to start with the Vbat and the Vbat connection of this mobile PCB, because almost all Samsung PCBs are being connected in the same way. So I want you to understand the Vbat and the Vbat connection of Samsung PCBs, because those are the most important connections that you have to check when you are troubleshooting problems like power problem, dead mobile and charging problems. You understand? So what we have right here is the battery connector, and it always starts right here. So this red pin right here is the Vbat, which is the battery positive. So once the Vbat leaves the battery connector, it has only few components right here, which are not that important, because if you look right here, you will see that we have a fuse resistor right here. This whitish component right here is a fuse resistor, a low value resistor. So when the Vbat leaves this resistor, where does it go to? Instead, you might think that it's coming right here, in case you already know that this is the power manager IC. This is the power manager IC of this PCB, but instead of the Vbat going to the power manager IC like in other PCBs, it's not going to this power manager ICs. So understanding this, you will know that, okay, if this phone is not switching on, instead of just going directly to the power manager IC, there is something in which I need to check, which is like the gateway of the Vbat voltage. And I'm going to show you that. I'm going to show you the connection and how it gets to this power manager IC, because you can see directly right here that the red V line right here is not going to the power manager IC. This is the line right here. It passed right here and it's going somewhere. So we are going into the bit mapping, and I'm going to show you something right here. So right here we have our bit mapping, and I'm going to zoom in, then explain what I'm talking about right here. Okay. Just for you to understand, in case you are looking right here and you are not understanding something. This is the PCB that we are working on, but it's in bitmap format. It's in the bitmap format. So we have our battery connector right here, and I'm going to click on it so that you will see the connections. Okay, I will need to zoom in well right here. So if I zoom in right here, you will see that the line is really clear right here. It displays a line, which helps for you to do easy jumper and know where the inner layers of the connection is in. Yeah, in case you have to scrape before you solder a jumper. You understand? But that's not what we are talking about right here. So when you see that the Vbat voltage leaves the battery connector, it gets to this fuse resistor right here that I showed you before. So we are going to start from the fuse resistor to check where that Vbat is going to. Okay, cool. So when you click right here, the connection's supposed to show where the output, which is the output voltage of the fuse resistor right here, is going to, which, like I said, normally in almost all PCBs, it's supposed to go to the power IC, which right here, this is the power IC. But if you check, you will see that there is no connection. There is no Vbat connection right here. So where does it go to? So if you check on this other section right here, okay, cool. So if you check on this other section right here, you will see that it's coming to this IC instead. So which IC is this? This is the charging IC of this mobile PCB. You understand? So the connection of the Vbat of this phone doesn't go right into the power manager IC when you plug in the battery. It goes to the charging IC first before it goes to the power manager IC using a VPH connection in the VPH track. You understand? So what is this VPH that I'm talking about? Once the Vbat enter the power manager IC right here, you will have the output, which is still a Vbat but a VPH connection that is going to the power manager IC input. You understand? So the VPH that I'm talking about right here is right here. It's right here in this coil right here. So what we have right here is a coil. You might not be able to recognize it right here, but if I go to the PCB guideline, you will see what I'm talking about. So if I come right here to the guideline and I find the charging IC, you will see what I'm talking about. Okay, cool. So if you look at the power manager IC right here, you will see that the Vbat enters right here, which is from the fuse resistor that I just showed you, and we have the output. This output right here is instead the input of the power manager IC. So you can call it the VSYS connection or the VPH connection. So this is the V part of the power manager IC of this PCB. You understand? So if you are trying to troubleshoot power problem on this PCB, so instead of starting with the power manager IC, which is this right here, you have to start with this IC because the connection needs to pass right here in the charging IC before it goes right there. So like I said, this is the VPH connection right here, and I'm going to zoom in the connection so that you will see what I'm talking about. So once we get our input voltage, which was right here on this capacitor, we get the Vbat voltage. We're supposed to get the output voltage right here, which is going to the power manager IC. So if this PCB is shorting in this VPH line right here, there will be a full shorting on this PCB because it's normally a Vbat connection. So I'm going to zoom in right here. So if I zoom in right here, you will see that, okay, this is the point in which voltage is being supplied on these PCBs. Because you can see that even in the network section, the standby voltage in the network section is being distributed from that particular VPH line. The power manager IC gets its voltage right here, then the network section gets its input voltage right there. You understand? So let's talk about the V-bus connection, which is very important. It's almost the same like the V part, but there is a difference right there. So we have our PCB guideline right here, and this is the V-bus. The V-bus from the ground board of this PCB is on this particular pin of the display connector. So the V-bus, which is the charging positive line, is on this side of this connector, is on this particular pin of this connector. So if you are troubleshooting charging problem on this mobile PCB, which some of them will be different, but you have to follow the same steps to troubleshoot charging problem. So if you are troubleshooting charging problem on this PCB, for example, you will first have to check that if there is 5 volt right here on this particular pin, because normally when you plug in the charger, the 5 volt from the charging system is supposed to come right here. Then from here, where does it go to? Okay, so from there it comes directly right here. Most people think that this component right here is the charging IC. This is not the charging IC. We call this OPV. It's just for voltage protection of a mobile PCB. This particular IC right here, this is not the charging IC. And if there is a shorting right here in these ICs, it will completely short the V-bus of this PCB. You understand? So when you are following, you have to check if the PCB has a voltage protector, which is OPV. You understand? So if you check and you see the 5 volt right here, you have to come to the charging IC itself. So where is the input voltage of this charging IC? So you can normally see right here we have V-bus in, which is the input voltage. So when we have the V-bus in, then the output voltage, which will charge your battery, will come out from the V part right here. You understand? And there is something really different about this type of charging IC. You see that this type of charging IC right here on this Samsung phone is not the type of charging ICs that we mostly work on. It has a lot of integrated circuit, like it deals with the DM and the DP of this mobile PCB. Instead, let me show you what I'm talking about right here. instead of other phones that have the VBus, the DM and the DP, which the DM and the DP is going directly to the CPU after the charging port. Instead, for this PCB right here, the DM and the DP goes directly to the charging IC right here. You understand? So there is no direct connection between the charging USB positive and USB negative with the CPU. Instead, the direct connection with those pins are with the charging IC, because this charging IC right here, as you can see, it's big and it has a lot of integrated circuit. That is why if you zoom in right here, okay, cool. So that's why if you zoom in right here, you will see that we have the DM, the DP pins right here, which is the input, which are coming directly from the charging card, and we have the DM and the DP, which is the output, and these ones are going to the CPU. Do you understand? So for example, if your phone is not reading on a PCB, even when you change the charging port, then you try following, there is no open circuit between this line, then the first thing that you will need to check is to change this charging IC right here instead of reballing the CPU or changing the CPU. You understand? So once we have the VBus input right here, you're supposed to get an output voltage right here, the Vbat, which charges your battery. And you need to understand one thing again about Samsung PCBs. Most of them, you won't get an output voltage in the Vbat right here when you connect the charger into the phone. Instead, the pin in which you will get a voltage in, you will get a voltage in the bat on. Right here, you will get a voltage in the bat on, which is one of the middle pins of your battery connector. So when you get a voltage right here, it might be between 1 volt to 2.5. You understand? So if you are troubleshooting charging problem and you don't see any Vbat voltage when you connect the charger, make sure that you check the bat on voltage right here, which is in one of the middle pins of the battery connector. If you see a voltage right there, then you can now connect your battery to see if that's working. Even if it does not work, then the problem will be right here. Because when you check and you see the voltage right here, as soon as you plug in the battery into the phone, the battery now will then give a signal to this to this charging IC right here to give that output, Vbat output, to charge the battery. So these are all about transistors. These are transistors work, integrated transistors work in this charging IC. They enable signals. They receive signals and switch on voltage in different sections. You understand? So this is what I want you to understand for now about troubleshooting power problems on a Samsung PCB. You understand? So in case you want to learn more about any type of PCBs, mobile phone problems, in case you want to learn more in just a short time, make sure that you message me using this number on the screen right here, because I have a complete mobile repairing course in which you can learn everything in just a short time. The course is not free, but the price is fair. You understand? And believe me, you will learn a lot from it. So goodbye, and if you haven't subscribed to this channel, make sure that you give a subscribe right here and become part of the family. Thank you.
Hi everyone, what do we have here? We have this mobile PCB received from another shop or a technician, and the PCB is not powering on. So the first thing, I had to connect it to my DC power supply through the charging port to monitor the charging circuit. And as you can see, that's a clear current trigger in the charging circuit, right? Which shows that there is a short in the charging circuit. As you can see, the current trigger is really high. So because of that, I knew that there was a short, and I tried to feel if I will get any heat in the PCB, because that's a high current trigger which will normally cause even a small heat in the PCB. So I was filling up the heat to see if I can feel the heat, because I don't have a thermal camera, and there was a little bit of heat coming from the PCB. So because of that, I knew that there was a short, and I had to go on then actually check the VBus line of the PCB. So first I checked the Vbat, and the Vbat was okay, so I had to look up the PCB from the connector heading to the downboard to see if I can identify the VBus pin in the connector so that I can test. So that's what I was looking at, and looking at the connector, I knew where the VBus is. And as you can see, that's a short in the VBus line, which shows that yeah, there is actually a short in the VBus line in the PCB. So we will see how we can troubleshoot this fault, and yeah, you will learn a lot from it, learn a lot from this video. So subscribe if you are watching this on YouTube, give the video a like, and follow if you are watching this on TikTok. And also don't forget to get my courses. I reduced the price of my basic and professional level course. You can check it from the link in the video description on my bio, or send me a message on WhatsApp if you want the courses. You will learn everything from the basics. So I removed the shield, and what I was looking for the OVP IC, because this is the first IC that the VBus voltage passes through before it gets to the PCB, to the charging IC for protection, you understand. So I test the capacitor, and yeah, that's a short right there, and I had to test everything again just to be clear. So I tested, as you can see from the other screen, the one that I added, I was testing the capacitors and it shows a short. This one right here, that's a coil that passes the VBus voltage, and that's okay to beep in both sides, but not okay to beep when you are testing it to ground. So also that capacitor was shorting, which shows that there is an abnormal reading here. There is a short there, right? So it was very clear. So I had to confirm if the OVP IC is the one heating up, or if there are other components like capacitors around it heating up. So we had to spray our rosin flux in the PCB, then inject voltage in the area. So just look at what I'm doing here. So I sprayed it, set our voltage to 4.5. that's still okay. Then I had to inject the voltage. Just look at what I did here, how I did it. So I just placed my black probe to the ground, use the red probe to inject voltage, and boom, that's easy, right? So the video is not done yet, because when I did this, I noticed the OVP is shorting. I know how to jump at the OVP, and I thought that the OVP was the fault. So I was removing this thinking, yeah, everything is okay, the phone is going to work, but nope. So that's why I said you will learn a lot from the video. So those who back up from here are going to miss a lot. Yeah. So look at what I did here. So you need to be watching this, having the mindset that I'm solving the problem by removing this, so that you will learn when you face this kind of difficulties. Because I was removing the OVP IC thinking that I'm going to solve the problem, right? So but I did not. So I removed it, the OVP IC, and I had to jumper. It's very easy to jumper, right? So the OVP IC doesn't have any big function in this area, just to protect from the name OVP, it's over voltage protection IC, protects the voltage going to the charging IC, right? So which means that there is a very easy method to jumper. You can just link a cable from the inductor, which is like a resistor, to the other capacitor in the other side. So what I did, I just connect the pins from the charging, from the OVP IC pins. As I remove the IC, right, there are two pins that are connecting both of the resistor that I'm talking about to the other IC, to the other capacitor in the other side. So I had to test to see if there is still a short, and there was no short, right, which confirms that the OVP IC was the one causing the short. So all I had to do now to connect, to jump out this area, like I said, you just have to link so that there will be a continuation in the line. So that, yeah, so that's what I did. Just connect those two pins. Those are the two pins that are connecting the voltage from the inductor to the other capacitor, big capacitor that you see. So I tested, and everything was okay. So I put in the phone, and thinking that everything will be okay. The phone did not charge at all. No signs of powering on, and no trigger, no current consumption in the DC power supply. So because of that, I knew that there was a problem in the charging IC. Yeah, looking at it right here, you can see that I already removed the charging IC. I did not record this because my phone was low, but I removed the charging IC because I had to replace it. So it seems like even though the OVP IC protected the over voltage or any fluctuating voltage from getting into the phone, yeah, it did not succeed in stopping the voltage from getting into the charging IC to damage it. So we had to work on the charging IC. So as you can see, I have removed the charging IC, and what I'm doing right here, I'm swapping the charging IC just from another PCB. So this is the other IC from the other PCB that I removed. So all I had to do, I clean everything up. So just look at how I'm doing everything. And again, about my courses, you will learn a lot if you get my courses. If you are someone who always wanted to learn mobile repairing, following me, wanting to learn all my troubleshooting skills, you can get my courses. My professional level course, I keep it updated. So if you get the courses right now with future lessons that I'm adding, you are not going to pay for that, because I keep adding. We learn every day, and when I learn, I upload it. When I learn something new, I make sure to upload the video in the professional level course, so that everyone will stay updated, right? So what we are doing here, we are reballing the IC swapped from another board to the PCB that we are working on, and that's the charging IC. So that's the charging IC. So in case you are wondering how exactly I suspected the charging IC, I know that this was the position where the problem was coming from. This was the IC that was causing the fault, even though the short was gone. It's because I connected it to my DC power supply through the charging port, right through the USB port, and there was zero current consumption even when the battery was connected. And I knew very well that my connection in the OVP section is okay, that jumper was okay. And also I connected it to my charger that shows the current consumption. There was no current consumption. And when I try to power up the mobile PCB, right, so with a single click in the power button, the current goes up to 120 milliampere. So that might seem like it's a different IC causing the fault, like the CPU, but if you monitor how the current behavior is, and also if you monitor that there is no single current consumption when you connect the phone to charge, you will notice that you have to start with the charging section first before going to any other section. So that's how I troubleshooted this phone to know the exact side that is causing the fault. So I place the charging IC, I put everything together to test if the phone is working and if the phone will charge, and yeah, seems like everything was okay. As you can see, the phone powered up, and I love to connect the charger, and everything is good. So don't forget to get my courses and follow me for more videos. Don't forget to like the video also. Thank you and see you soon. What is the perfect way to remove shields in a mobile PCB when you are troubleshooting? As a mobile phone technician, you will learn this in this video, and it's very important when it comes to troubleshooting, especially phones that can actually power on. So working on this type of phones, you need to be extremely careful, because overheating the PCB will cause serious damage to the PCB. So first you need an IC polishing tool like the one that I'm using right here to cut the specific part in the mobile PCB that you need to troubleshoot. So you can use this method if the specific part that you want to work on is actually small and you don't want to hit the shield all around. Like as you can see, the shield is very big, right? So there is actually no need for me to cut the shield all around, but some people will prefer to remove the shield all around. But for me, I always prefer to cut the specific part that I'm working. As you can see, that other small side of the shield is where I have to work on, and after cutting it, I have to create a little hole at the corner. This is how I always do. You see, I have to create a little hole at the corner right there, because I have to hit that corner. And also I have my new mobile repairing ebook. You can check it from this video description. It's very good, or check the link on my bio if in case you are watching this on TikTok. It's very good and very cheap with over 83 pages, so that's actually good. I have to hit the specific place that I want to remove, then send in my tweezer to that little hole. As you can see, just like that, very smooth. So when I hit the PCB, I don't have to use much force. Then just like that, I lift up the specific part that I'm working on without risk in the PCB. No matter how careful you are when removing this shield, it doesn't matter the temperature that you use, you can still cause some open circuits in other ICs when removing it. So you have to use the perfect way that you can. As you can see, that's how I always do. I just remove that specific part. I work on it just like that and very smooth. So subscribe for more videos.